Okay, everybody. Today's lesson's on stream development. We're going to go right through from young stage to old mature rivers. So let's start things off right away without wasting any time. First of all, young streams. You can see it right in the picture here. They have V-shaped valleys. That's because they're usually in steep areas. They're down cutting, eroding downwards very fast, and that creates this V-shape profile. They have usually rapids, waterfalls, fast-moving white water, very turbulent. And not yet, there's no floodplain developed yet. Usually these things will eventually form floodplains, but it takes many, many, many years, thousands of years, perhaps millions of years to form floodplains. So young streams are really just flowing very fast and steep with these waterfalls and rapids. There's a picture. You can see a V-shaped valley. You can see some white water in the foreground, definitely rapids. Rapids. Different resistance among rocks cause fast-flowing water. And you can see in the diagram on the right-hand side the waterfalls and how on the surface there's a rock type. In this case it's dolostone right here. And this dolostone is harder than the rock beneath it. This shale is weaker. It's being back cut like that. And another layer of dolostone there is harder. This is shale, by the way. And perhaps this is some siltstone. It's a little bit harder than the shale, but weaker than the dolostone. This looks like some sandstone, and that's definitely harder than the other rocks. Maybe not the top rock, but it's harder than the other layers. And then some weaker shale on the bottom again. But you can see that this top layer right here is very resistant, this capstone rock, and that's what's causing the water to fall over like that. Eventually that rock on the surface will break and fall in. All right, let's see if we can get this thing to work. Here we go. To discover how waterfalls form, press next. So let's try it. When a river flows over layers of hard rock, the softer rocks are more quickly eroded downstream from the hard rock. And you can see it right here, how when it flows over layers of hard rock, in this case, here's our layer of hard rock. I can't draw on this thing, won't let me. But it quickly erodes the softer rocks around it, but not the hard rock. Whoops. And so over time, that softer rock starts to back waste or back cut. And that forms our waterfalls. Now eventually, that turbulent water at the bottom of the waterfalls will back cut the layers underneath even more, and pieces of that top section will fall in. And that's why at the bottom of waterfalls often you find boulders and things underneath the water. And that's how gorges are formed. And we have some of those right around here. And this process will keep repeating, and the whole set of waterfalls will move backwards upstream. And this has happened with even Niagara Falls. It's moved upstream over the years. And there's Niagara Falls, speak of the devil. This particular set of the falls is the Horseshoe Falls. This is on the Canadian side, and they haven't really done that much on the Canadian side to keep that capstone rock, that Lockport dolomite, which is the rock you see on the surface here, from eroding. So over the years, this rock collapses in to the Niagara River and moves upstream. The American side, in contrast, they did a major project there many years ago where they actually stopped the river flowing over that falls, the American Falls, reinforced it with steel and concrete, and reopened the falls. And now the other side, the American side, doesn't back cut as much. Stream development. Now in the mature stage, you'll notice some differences here. It starts eroding side to side. It's widening the valley, and that's because slope is decreasing, so the water's going somewhere. It's putting its energy off to the sides, and that's flattening things out. And remember, we call that back and forth movement meandering, so it's more pronounced in mature streams. And that's where we get our floodplain, which is where the village we're in right now is built. So as the stream grows larger, begins to shift its course in a series of bends or meanders, seeking out the lowest elevation. And over time, those meanders will migrate. They'll move back and forth across the valley, continually changing its shape. It's dynamic. All right, let's see if we can get this thing to work. All right, so here we have a meander. Over time, there's our profile of the meander we already learned about last week. Another meander, but you can see on the outside of the curve, it's moving faster than on the inside of the curve. And on the outside, it's going to erode, whereas on the inside, it's going to deposit. Remember, we learned about the cut bank on the outside versus the point bar on the inside. And I think this is just repeating over and over again, but you get the idea. Over time, and I can't draw on this video clip thing here, over time, that big meander in that picture is going to migrate towards the top right-hand section of this, this slide. And over time also, you might get a flood which would cut off that meander. And we're going to learn what happens in that case in a moment. So there's some meandering right there, left and right. Point bars show deposition, cut banks show erosion. So once again, here's our cut bank on the outsides. It's cutting into or eroding the banks, another one over there. And on the inside, this is our point bar where it's building up a layer of sand or gravel. Another point bar there, point bar here. And the water's moving slower on the insides, and it can't carry those larger sediments, so it deposits them. There's a nice photograph showing a cut bank on the top. And you can see it's collapsing into the stream. And the bottom photograph shows a nice meandering stream with a huge point bar located right here. Point bar. It's probably sand and gravel. And there's another cut bank on the left and a point bar with the man standing on the right. All right, here's a question. Diagram below represents cross-sections of a stream through points A, B, and C. And we are supposed to figure out which choice is correct. And A, B, and C up here in this question are on a meander. And so you have to remember that point C is on the outside of the curve where it's going faster and therefore eroding deeper. And point A is on the point bar side, the slow side, where it's depositing. So we're looking at a choice where it's deepest at C. And that would be choice 3. Hopefully you had it. Some more pictures of point bars and cut banks. I believe that's in Alaska. Old age. Now in old age, these stream valleys widen considerably. Very wide floodplains. The land is worn down. It's very flat. And you get these new formations called oxbow lakes. And you can see they look like kind of like bananas or really big curved horseshoes or something like that. And there's an oxbow lake, another oxbow lake, another oxbow lake. And these were former meanders in the river that were cut off during floods. So eventually it takes too much energy to keep meandering. So rivers, which are lazy, will cut off a bend, resulting in an oxbow lake. That happens during floods. You can see right here how if the river's flowing around, whoops, won't let me do that. Let's go back again. There we go. If the river's flowing around, in this case, let's say it's flowing to the right-hand side of this screen, over time, during a flood, it might actually jump over that narrow part, that inside part at the bottom center, the neck, and that would make a straightaway and leave this abandoned meander channel behind, which is called an oxbow lake. You can see it right there. And that's a very old stage river. You can see it's meandering like crazy back and forth. And I don't know if I'm going to get this thing to work. Doesn't look like it. That's okay. And let's try this one. Okay, I'll just keep fast forwarding through. You can see how it changes. It's migrating. These are dynamic systems. And over time, it gets really close right there at that neck, and then during a flood, it's going to hop it. And once that river meets itself, forget going around the meander. Water's lazy. It's going to go straight ahead. So it's going to form an oxbow lake. That center section will deposit in and leave that thing abandoned behind. And there's a bunch of these up and down the Mohawk Valley. And sometimes they'll even dry out, form a meander scar. And in this picture you can see some oxbow lakes. The main river channel is on the bottom right-hand side of the screen. The oxbow lakes are up above. There's another oxbow lake, which is probably drying out and will form a meander scar at some point. And in this particular question, what's the correct sequence of stream development? So we're looking from youngest age to oldest age. So we're looking for the thing that has probably the steepest gradient would be the youngest. So look for mountains and streams flowing in the mountains, and that would be D. And the oldest would be the widest with the most meanders. So this would be first, and this would be last. And then we have to find out which two fit in the middle. And it looks like this might be second. Starting to meander more here, so third. There's even an oxbow lake right there. And then last is fourth. So you often get questions asked like that. All right, levee formation. Let's see if we can get this thing to work. Now levees form after a flood. That water that floods out there deposits a lot of its sediments on the sides, and that forms a natural barrier, which we call a levee. And that kind of keeps the water in a nice channel normally until the next flood. And that's it. Hopefully you guys learned something about stream flow and young streams versus old streams.